And now, from the Spotty Dog Studio, deep in the heart of Texas, this is Chuck and Karen Robison and our show,
What If It Really Works?
I see. I didn't know I had these experiments in the past on those, reverse causality sorts of things that they had done, the constraints.
Yeah.
I didn't know that.
Yeah.
Because I thought that would be a good one. That wouldn't be that hard to do, you know.
Yeah. Well,
and you can see the
many
constraints.
things have been tried.
Yeah.
So you
So
could
there are other
easily do
things.
experiments with random numbers. I mean, there's
Sure.
easy ways of doing that
Right.
kind of thing.
Right. Paralabs has been doing that for 2 generations.
Yeah, but it was the same experiment more or less over a long time. But if you come up with new designs, it's relatively easy to take a Celeron or some other device and program a little thing and try it.
Yeah, I suspect with your being an experimentalist, that between the two of us, we could come up with, quite a few of these, predict something that's never been done before, and then go do the experiment.
Let's do it.
I'd really like to do that too.
Okay, we got to end this because we're working.
Yeah, I think that'd be wonderful. Because there's no point. I mean, the theory isn't any good if it doesn't.
So here's something we're in the process of building. We have an online version of our double slit experiment. We're making an online version of a random number generator experiment as well. So it's going to be extremely simple to begin with because it's going to be part of another project that we're doing. But the guts of it would be fairly easy to change. Like from the perspective of somebody who's using the experiment on the web, they see a squiggly line. The squiggly line is some kind of feedback, but what's actually going on underneath can be very complicated.
Sure.
So that could be a way of plugging in some of your ideas into this and getting
all you need in that complication is something with enough uncertainty that it's movable. If you get things that are, that the uncertainty is in the 12th decimal place, now unless you have measurements in the 13th and 14th and 15th decimal place, it's just not going to be good.
Bits, so
as long as you have things that have flexibility within the uncertainty, you should be able to move that with intent.
Right.
And the more focused intent, the bigger the push. That's how placebo effects works. It's intent modifying future probability. That's how ice cubes are frozen with pretty crystals or not so pretty crystals. It's intent modifies the way you hear the thing about no two snowflakes are ever alike. Huge amount of randomness in the way ice can freeze and the structures it can take. So within that randomness, if you have an intent, you can modify the future probability of how that intent plays out. So
I think we've wrapped it up. I mean, there's nothing else left to talk about.
We can go get to work. Right? Yeah. So I think it'd be good. I'd love to work with you, and produce some really tight experiments on things that have never been done before, and make the predictions. That would be. I mean, that's what science is all about. I'm a scientist too, and I would like very much to do that. That would be terrific. I was hoping we might end up someplace like that when I came here.
All right then.
You're the experiment guy.
Well, you push the probabilities in that direction.
Yeah. I did. Yeah. So that'd be a whole lot of fun. Yeah. Yeah. If you're interested in the kind of the long version of the theory, it's all on YouTube. So you can find it.
I've seen some of it.
Yeah, you can find it there. I usually
have
have
in this too? It's like, is this?
Well, yeah, that was an interview, so I was responding to their questions, and some of it's in there, but it's kind of however our conversation happened to wander around on that day. It's not focused really at that. In the YouTube with like the Calgary one, I have a Friday, Saturday, and Sunday. Friday's just kind of introduction and a quick summary. Not a lot of data there. The Saturday is all the theory, which is the one you'd be interested in. And then the Sunday is the applications. remote viewing, healing, that kind of stuff. How to do it? How does it work? What are the parameters you can use to manipulate, and what are the parameters you can't? And what do you expect? And, we talked some out-of-body stuff and whatever. It's kind of applications of it. But if you just look at that Saturday, you'll have pretty much all the theory.
Okay.
Wrapped up. So that would be a lot of fun.
Okay, we got it.
Anything else, boss? That
Y'all are wonderful. This is wonderful.
Anything else you wanted to?
Well, we didn't know exactly how this was going to go. It's going brilliantly. Do you feel like you've gotten something out of this that you wanted, Dean?
I never want anything out of an interview. It's not about me. It's about what you want.
Yeah, I agree.
You have something for your viewers.
Yes, yes. We have quite a bit for our viewers. And I wonder if there was some way that we could, at the end, from both of your perspectives, based on where we are right now, what could our viewer do right now that might improve their experience of their consciousness, starting with you, Dean?
Oh, that's easy.
Good.
They should buy this book. This will improve your consciousness to such a degree you will not believe it. That's...
It's a true statement.
Yeah.
And why is that a true statement?
Well, because it's based on empiricism. It says that regardless of what you may believe or what faith you have or whatever else, when you put certain ideas to the test in the laboratory, you find that they're true. Because essentially an experiment asks the universe a question and it gives you an answer. And if you're lucky, you ask the right question and you're paying attention to the answer. Mm-hmm. So the answer says here that a fair amount of things that people consider to be psychic are very likely to be true. What that doesn't say is that any particular experience that you may have is indeed psychic, might be a coincidence or a mistake, but that we know in principle that they're true.
So you've actually proven to the satisfaction of your publisher and the people that are reading your book that this is a solid experience that people are having, and it's beyond the business of maybe and what if and wishing.
Absolutely.
Science is not really about proof. Mathematics is about proof, and alcohol is about proof. and logic is about proof as well.
Yeah, right.
But science is about evidence. So what we can say is that for several classes of psychic phenomena, that the evidence is so far beyond chance, and very likely not to be artifacts or mistakes, that for all intents and purposes, the phenomena are real. But I would not say that it's proven.
Yeah. It's just the terminology, it used to be a long time ago that physicists created laws, and we had Newton's laws, we had Maxwell's laws, we have all these laws, and then physicists got a comeuppance from nature. The laws weren't really laws at all. You see, all the things they said were laws, well, actually they're not laws. They hold in a certain area. And then scientists stopped using the word laws, and they started using the word theory. Everything is a theory. Now, in the popular culture, theory means you're making a guess. What's your theory on who done it? You see, and we kind of have this sense of a theory is you kind of make a guess or a swag or what you think it might be. But in science, that's not what a theory is. In science, a theory is kind of a hypothesis, if you will. A model is another way to say it. And the point isn't do you prove it or not, it's does it work? Does the theory actually enable you to predict what's going to happen? Does it explain all the things you know that happened? Does it explain everything that people knew, in times past? That sort of thing. So if the theory works, then it's a good theory. But
it's always provisional.
It's always provisional because we've learned as soon as you start to believe that you know everything and you've got all the edges tied down, you just make a fool of yourself. So nobody talks about, proof in science, at least not good scientists. Good scientists always leave it open-ended. You can always learn more and never say that you know the final last piece of information about almost anything. You have very simple things, yes, you can do that. But as the structures and the things you're talking about are more complicated and complex, it's just either good theory or bad theory. And good theory works, and experiments verify it. And generally, it has just a few very basic assumptions. That's kind of, that's another thing of good theory, at least if it's fundamental stuff that we're talking about. If you have to have a lot of assumptions to prop it up, then even if you can kind of describe what happened before, well, you can almost make any theory fit if you have enough assumptions with it. So just Einstein had a quote that it's like the point of science is to describe as much as possible with a few assumptions as possible. So that's the hallmark of good theory.
Make it as simple as possible, but not too simple.
Yeah.
That was the other quote.
Yeah.
It's true that you want Occam's razor here to make explanations as simple as you possibly can get it, but the simplicity oftentimes is because our brains are little pea brains. We're simple. Nature can be incredibly complex, but we tend to see simple explanations as more elegant. But nature, I don't think, gives a whit of what we think. I mean, it's way more complicated than any one individual can cram into their head.
So can you prove it is really the wrong question. It's what's the evidence?
What's the evidence? The evidence is really, really good.
Yeah, the evidence is good. And you look at Pear Labs, and I listened to their little video. If you go up on Google, PEAR Labs, Princeton Engineering Anomalies Research, and they have a little video right up on their homepage. And he will tell you that if you look at all of their experiments done together in one ensemble, the probability that their results were just freak, an accident, just happened that way, random good luck, is less than 1 in a billion. Now, what science works to that level of exactitude? Mostly, if we get 1 in 1,000, we're happy, and 1 in 10,000, we're deliriously happy on most research. But 1 in a billion?
Well, 1 in a billion is technology. I mean, it is. So like this device wouldn't work if you had error rates more than more than 1 in a billion. So there's the transition between the edge of what is known and things that are known well enough, so you're able to make devices.
Right. Exactly. So here's Pear Labs, but see, they can't get their work published. They have a hard time taking it to mainstream scientific publishers. These are credentialed, good scientists. They're Princeton University, not Cornflake U someplace, but they have a hard time. And we have this problem with, well, can you prove it? No, well, then it's BS. That's not the idea. They will tell you they can't prove it either, but 1 in a billion that their results are accidental, you see, that's evidence. That's really, really, really strong evidence, but it still doesn't get a whole lot of credibility in the larger scientific community because it runs counter to the belief, the scientific belief that we live in an objective reality that you can't do that. That's not possible. So that's kind of the problem we have. So I get a lot of that too. Can you prove it? And it's all, that's not really about that at all.
That's when I hand over a little bottle, those little like airplane bottles they used to have of vodka. Like 150 or almost 200 proof. Want proof? Here's proof. That's the best we can do.
Yeah.
So I'd like to ask both of you in turn, and starting with you, Dean, as you look ahead 10 years, where are we going to be on these subjects?
In 10 years, we might be very close to where we are today. The science is a very slow engine to change. There could be a breakthrough. It could be a theoretical breakthrough. Don't particularly see one on the horizon. But you never know with quantum mechanics. There are all kinds of new strange effects that show up practically every week in science journals now. So maybe there's a breakthrough. Maybe things will happen radically fast. It could be that the environment is changing fast enough so we'll be forced to make new decisions about what we're going to believe or not believe because we don't have any choice about it. But if I had to guess, I would guess that 10 years from now we're going to be quite similar to the way it is now. There will be more evidence. There will be better evidence in terms of psychic, mystical experience, that sort of thing, and what science can do with it. There may be an opening within the neurosciences for more interest in this topic because of increasing interest in meditation research. And I'm an optimist. So I hope things change quicker, but I don't know, obviously.
Tom, where are we going to be in 10 years?
Well, I agree with Dean. You know, if you look at how these ideas have been in our culture, you know, for what, 6,000 years or more, they've always been in the margins. You know, there's always been people who had a sense of the larger reality. Most of them have been called mystics or, you know, right-brained or whatever we call them, but they've always been in the margins. There's always been paranormal things going on, records made, experiments done. It's not like this is brand new and suddenly, you know, everybody's going to look at these experiments that Dean does and say, well, you know, gee, that must be right. They'll look at his experiments and they'll shake their heads and they'll go, yeah, but it doesn't make sense, and then they'll forget about it and they'll go on doing whatever he's been doing. So it's been in the margins a long time. I have hope. I'm an optimist too, and I see that there's two major paradigm shifts that we need to get to and through. The first one is that reality is information, that this is not an objective reality. It's a subset of a bigger picture. You know, there's a bigger reality out there, and what we see here in this physical reality is a subset of that. Just like I said, just like Newtonian physics is a subset of quantum mechanics. So I think that idea is gaining. I've seen in the last decade a huge gain in the number of scientists that are taking the idea of this being a virtual reality and our reality being based on information seriously. So I see that as a growing, it's still in the margins. It's still even pretty far out on the margins, but it's
respectable.
It's respectable.
Yeah.
You have a whole group now called digital physics that didn't exist before. And these are people who start from that premise that this is a virtual reality.
Yeah.
They publish in you know, standard traditional journals. Mm-hmm. So we're beginning to see, you know, a turning, I wouldn't say we're at a turning point yet, but we're beginning to see that this has become credible. And the fact is, it's just better science. You know, you can explain all these things that are unexplainable when you understand that reality is information. Suddenly, all this mysterious stuff just falls out as logical consequence. So I think that's the first step, is that, and I believe we're continually gaining. 10 years from now, that's a pretty short period of time. But I see this trend continuing to blossom and blossom and blossom because it's undeniable. Just like that the Earth is round rather than flat. You know, that idea lasted a long time and was let go of, you know, not very easily. And today we still use the concept that the Earth's flat. It's called surveying in small plots. You know, it's all flat Earth assumption. When you lay out a house, you know, a survey for a house or a shopping center or something, you assume the Earth is flat. So it's a good approximation for short distances. Anyway, I see this as a developing snowball rolling down the hill. It will gather steam because it's better science. So eventually the flat Earth kind of rolled up into a subset for short distances, and we got a bigger picture. I think we're headed that way with this. So that's step number one. First big paradigm that has to shift. Then the second, and that's going to create a ruckus. That's going to create a lot of dislocation in people's concepts. The second thing that has to happen is that then they have to realize, you know, when you say this is a simulation, the first question is, well, who's the programmer? You know, who's doing the simulation? And the second paradigm that has to shift is consciousness is the computer. And then when we get those two together, suddenly everything from, you know, the Buddha saying that this is an illusion to, you know, God is love, to paranormal events, to quantum mechanics and relativity and reverse causality and all this stuff then just falls out with placebo effect, mental healing, you know, all kind of falls out as a logical consequence.
And step two is going to be much more difficult than step one.
Yeah, step two will be another huge step, but step one will be huge too, because, you know, when you listen, if you read Friedkin, and they said, well, where's it come from? You know, who's doing it? He said, other. He put quote marks around the word other. He says, don't know. Science doesn't take me there. It's just other. Well, science can deal with other. They just ignore it because, you know, the science doesn't cover other. They just cover it being virtual reality. But once the scientists, the high priests of Western culture, say that it's a virtual reality, And where does it come from? Oh, other. The population at large isn't going to just say, oh yeah, other, we just don't know about that yet, and forget about it. That's gonna throw in a grenade under the tent when other comes out. And you're gonna have a lot of turmoil following that idea, because suddenly science is now in the position of validating other as something that must exist, because a simulation cannot simulate itself. So now we have the high priest of science validating that other doesn't exist. Well, you can tell what that's going to do in general.
Yeah, that's going to be a clash over creationism and intelligent design.
It's going to be a huge mess.
Many scientists who don't want to go there because they don't like where it's headed.
Exactly. So that's going to be a big dislocation of concepts and ideas and people. But that then, the answer to that, of course, is what's other is consciousness. It's the larger conscious system. If it's information, the simplest form of information is ones and zeros. It's just the simplest thing. And if it's an information system, then it's, that it's consciousness, and that this is a virtual reality. Everything fits. From then on, all the mysteries get solved, and it kind of takes care of itself with a logical progression. So I see that as in the process. The snowball has already started rolling down the hill. This is a long hill. It's going to take a long time to get there, but the more it goes, the faster it gets. So that's kind of my sense. I don't know whether that's 20 years, 50 years, 100 years. These kind of ideas take a long time to change something as fundamental as our idea of what reality is, that it's physical, it's objective, period. Otherwise, guess what? Scientific method doesn't work. Scientific method is based on an assumption of an objective reality. If it's a probabilistic reality, all experimenters doing the experiment anywhere aren't necessarily going to get the same answer. Scientific method has that as an assumption, that this is an objective, reality. So,
but we already know that that's been violated through...
Yeah, but we don't admit it.
No, well, local realism and non-local realism both have been shown to not be true. So, and this is mainstream thought. It's just, it hasn't penetrated very far.
Right, we just don't admit it.
The other thing about a virtual reality model is that if you have something running, it's a simulation, well, somebody can turn off the switch and reboot. And so the hope is that the world will continue to spin nicely over the next X number of centuries to give us the luxury, in a sense, of the luxury of science continuing to do what it does. And it is a luxury, because historically science has not been on the heap of the totem pole, and it's probably through that process, with stirring in a little ancient wisdom perhaps, that gives us the opportunity of actually advancing. Yeah. Because if we collapse too much into the direction of faith as the arbiter of truth, or too much in terms of people who don't have any time to think about it because they're worrying about tornadoes everywhere, then it's like a very fragile walk that we're walking, and I just hope that the future is stable enough to allow this evolutionary to continue.
Right. I would agree. And kind of the race we're running now is whether or not that wisdom, ancient or whatever, the wisdom of the people here is going to grow sufficiently that the technology that we're spawning, is used wisely rather than destructively. And that's,
or it doesn't accidentally kill us.
Yeah, it doesn't accidentally kill us, right? So that's kind of the race we're running. We need enough wisdom and understanding and big picture idea of what's going on so that we don't run ourselves over with our cleverness before we get there. So
I'm still an optimist.
Yeah, me too. Me too. Still an optimist.
You have to be.
Yeah.
You have to.
I think it'll be sooner rather than later. And when I'm talking about culture, sooner might be 100 years. But big cultural things are like, millennia. Half a millennia sort of thing. So when I say sooner rather than later, 50 years. 20, 50, 100, who knows? That's all about the same. That's kind of near term in cultural things. So I think it will be near term because we have the internet now. It used to be that information took a long time to spread, a long time to share. And that's not true. They talk about internet time being fast. Well, these things grow fast, change fast, and can be neglected just as fast. but we're in a different world now as far as information goes, and ideas can spread and get worldwide in weeks that would have taken centuries. So I think the snowball kind of picks up speed from the fact that this is the information age, and it's not going to take 200 years before the Earth goes from flat to round, even though the experiments were done and it was obviously round, but it took 200 years before most people believed it. So I don't think it will be 200 years. I think we'll be maybe in the next 50, I hope. I think science has got to get to this virtual reality as a better physics.
So what we'd like to think is that the time you all have put together this afternoon is going to speed up that for people who are thinking about this and can get in touch with it and understand that you're talking about something that has the power to really reshape our world. And with that, Karen, say the magic words.
Oh, thank you. We're grateful for your time. It's been an exciting time to listen to the two of you sharing information. And what if it really works?
Thank you, Dean Radin. Thank you, Tom Campbell.
You're very welcome, and thank you too for bringing us together, Chuck and Karen, kind of making it happen, setting it up, and dragging me out here, and getting Dean away from his desk, and kind of making this whole thing happen. I think it's been fun.
Well, the pleasure is all ours. Thank you very much. Thank you both of you.